Okay, 12.7, properties of similar solids. We've already learned about what similarity means specifically with triangles and two-dimensional objects. Today we're going to take it a step further into three-dimensional objects. So similar solids, two solids of the same type with equal ratios of corresponding measures. The same type means that they're both cylinders, or they're both spheres, or they're both rectangular prisms. That's what the similar type or the same type is. Corresponding measures, those are parts of the figure that are corresponding, are like two radiuses or two heights or two lengths. Parts of the figure, they're in the same location. Similar solids theorem, if two similar solids have a scale factor of A to B and a ratio of their areas is A squared to B squared, that's the stuff you guys already know. Then the ratio of their volumes is A cubed to B cubed. This is what's new today. You already know this idea. So make sure that you understand that this can go in any order. They might be able to give you the volumes. You'll have to work backwards by cube rooting to figure out the scale factor. Take the scale factor and square them to become the surface area or area ratios. Be aware of the different ideas here. So there's a couple of examples here. Are the solids similar? If so, find the scale factor. The first two cylinders, we have diameters and we have heights. These are the corresponding measures that I was just talking about. So the diameters, I did 15 to 10 and reduced it to 3/2. The heights, I did 15 to 30 and reduced it to 3/2. Because both of those numbers are the same, that means that we do have a set of similar figures, which means yes, they are similar, and the scale factor is 3 to 2. If you have numbers that aren't as easy to reduce, you can just do 15 divided by 10 and get a decimal, and 45 divided by 30 and get a decimal. As long as the decimal is the same, again, it would still be, yes, they are similar. Number two, we have two spheres. We have a radius of 7 and a radius of 4. All spheres will always be similar because there's only one dimension that can change. If there's two dimensions that can change, that means that you can multiply one dimension by 4 and another one by 5, and that would make it not similar. In this case, there's only one thing that can change, so all spheres will be similar. Same idea with circles. Circles will all be similar also because there's only one thing that can change, the radius, or technically the diameter. That's the same dimension. So example number 3. Be careful that the radius is given here and the diameter is given here. So the first thing I did was change that diameter to a radius. Then I compared my radius to the radius and height to the height. This is the 15 and the 7 here. Because they're not easily reduced, I did 15 divided by 7, I got 2.14. 10 divided by 4, I got 2.5. Because these numbers aren't the same, I'm going to say that they are not similar. Moving on to another example. So the blue is the actual problem. It says solid A is similar to solid B. Find the surface area and volume of solid B. So this is all information on solid A. We know the scale factor from A to B is 5 to 2. Here's my surface area and here's my volume. First thing you want to do is start off with my side length ratio, which is what I'm given. Side length ratio, changing to surface area ratio, we square them. So it's 5 squared and 2 squared, which turns into 25 to 4. I used 25 to 4 and I plugged in the given surface area for the first figure, and then I solved this to find the surface area of the other figure. So you can do this two different ways. You can just do cross products like what I showed here, or what I've been showing you guys in class is 2,356.2 times 4 divided by 25. So you multiply the ones that are diagonal, divide by that extra number. If that's uncomfortable, actually write it out and solve it that way. So your surface area of the other figure is 377 centimeters squared. My volume ratio, again, we're going back to our side length. If I use my side length, I cube it to have my volume ratio. So 5 times 5 is 25, times 5 gives me 125, 2 times 2 is 4, times 2 is 8. This is my volume ratio. Did the same thing, 125 to 8 over 8, and use this volume that's given to us in the top position, because these are my solid A figures. The bottom numbers are our solid B figures. Again, multiply these two numbers that are diagonal, divided by 125. My volume is 476.9 centimeters cubed. One more example for you. So it tells us that solid 1 and solid is similar to solid 2 and find the scale factor. So in black, this is what's given to you. We know that they're similar. We also know that this surface area is 192, this surface area is 108. You want to think about where you're at in terms of what's given to you. We're given the surface area or area ratio of these two numbers. These two numbers are the area ratio. We need to figure out what the side length ratio is. So what we need to do is take what's given to us, 192 to 108. Always reduce first. When I reduce, I get 16 to 9. Then I'm going to square root it because I'm going from this to this. When I square root 16 and 9, my side length ratio is 4 to 3, which is what they were asking for.